On the previous video, we were classifying amines as primary, secondary, or tertiary. And here our focus is comparing classifications of amines to alkyl halides and alcohols, because the classifications of amines as primary, secondary, or tertiary is different from the classifications of alkyl halides and alcohols as primary, secondary, or tertiary. And so I've drawn a line between the amine and the chloride and the alcohol. For the chloride and the alcohol, or the halide and the alcohol, the classification as primary, secondary, or tertiary depends on how many bonds the carbon, the atoms, oxygen and halide are bonded to, has to other carbons. And so for a tertiary alkyl halide, whether it is primary, secondary, or tertiary is based on the number of bonds of the carbon bonded to chlorine has to other carbons. And for an alcohol, it's the same way. It's based on the number of bonds to the carbon that is bonded to oxygen from other carbons. But for amines, the difference is that the classification of the amine as primary, secondary, or tertiary is based on the number of bonds from nitrogen to carbon. And so this molecule is a nitrogen bonded to a tertiary carbon, but the nitrogen itself is primary, and so it is a primary amine. For nomenclatures of amines, the suffix for the priority chain is going to be amine rather than ane or al. And the longest chain is the longest chain which contains a bond to nitrogen. And so for the first molecule, the longest chain, the first molecule at the top left, the longest chain bonded to the nitrogen is 4 carbons, and we number from the end of the chain that is closest to the nitrogen. So these rules are similar to the rules for alcohols. So this would be a 1-butanamine, with the butan indicating the number of carbons in the longest chain, and the 1 indicating the carbon number in the longest chain that is bonded to the nitrogen. For the middle chain, the longest chain that has a bond to nitrogen is 6 carbons, and the bond to nitrogen is at carbon 3. So that is a hexanamine. Hexan for the longest carbon chain, and amine for the fact that the functional group it is bonded to is the amine. And then we have the last example on the right. We have a tertiary nitrogen, has 3 bonds to carbon, 3 alkyl groups, and the longest carbon chain bonded to the nitrogen is 3 carbons. And so that is the main chain. The suffix for 3 is prop, so this is a propanamine. Continuing with naming, one other note, if we have 2 nitrogens in one molecule, as in the example I've drawn at the top, then the longest chain that is bonded to the 2 nitrogens is the main chain. So this is a hexanamine. But because there are 2 nitrogens bonded to this 6 carbon chain, it's a diamine. So this would be hexane 2,4-diamine. So continuing with our nomenclature, we have on the same set of molecules, but looking at the next rule. A substituent on the carbon chain. So for the main chain, any carbon or halide or other group bonded to a chain in this carbon, a carbon in this chain, is going to be indicated by the carbon number that is bonded to. But nitrogen can have bonds to substituents as well. And so any substituent bonded to the nitrogen is indicated not by number, because there's usually only one nitrogen. It is indicated by an italicized capital N. So looking at our names, we can do the two examples where nitrogen has a substituent are the middle and the right molecule. So starting at the middle molecule, the longest chain bonded to nitrogen is 6 carbons. So that's our main chain. It's a hexanamine. There are no substituents bonded to any of those 6 carbons other than the nitrogen. But then the nitrogen, in addition to be bonded to the 6 carbon chain, is bonded to a 2 carbon chain. And this 2 carbon chain, because it's not the longer chain, is simply a substituent on the nitrogen. And since it is a substituent bonded to nitrogen, it is indicated in the name as N. So instead of a number followed by ethyl, indicating 2 carbons, it is N-ethyl. So we have N-ethyl 3-hexanamine, N indicating that there are 2 carbons bonded to nitrogen, and 3-hexanamine indicating that you have a 6 carbon chain, hexan, with an amine at carbon 3. And then we have our example on the right with the 3 carbon chain being the longest chain. It is a propanamine, but this nitrogen that is bonded at carbon 1 of the propanamine is also bonded to an ethyl and a methyl group. And we would list those alphabetically as N-ethyl, N-methyl, 1-propanamine, so that you know the location of the ethyl group is not at a carbon, but at a nitrogen. And then the N makes it clear its location. Continuing with our nomenclature of amines, let's look at this example. We have a hexanamine with a nitrogen at 2 and a nitrogen at 4. The nitrogen at 2 has 2 1-carbon substituents, 1 carbon here and 1 carbon here. The nitrogen at 4 has no substituents. And we would indicate the substituents for this molecule as N, N, because there are 2 methyl groups, dimethyl, then indicate where the nitrogens are on the main chain, 2, 4, hexane diamine or hexane diamine. If you have to insert a D for indicating there are 2 nitrogens, then you put back in the E and call it a hexane diamine. Next rule. listing the substituents on the amine in alphabetical order is still required. So just as all other molecules, when we had substituents, we put them in alphabetical order, we are still going to continue with this rule. So on our first molecule, our substituents, we can highlight in yellow. And our substituents are chlorine and methyl. Methyl is bonded to a nitrogen, so that is an N-methyl substituent. And chlorine is bonded to carbon 3. So we can write out those groups. Oh, highlighter, not highlighter, pen. Pen. So we have 3-chloro and N-methyl. And I know that C is alphabetically before M, so that this is 3-chloro N-methyl 1-butanamine. In the second set, we have our substituents as methyl. Yes, I gotcha. Methyl and ethyl, with the methyl being at carbon 5. That's the location of the methyl, 5-methyl. And the ethyl being at the nitrogen, N-ethyl. And N-ethyl is alphabetically before methyl. So we would have N-ethyl 5-methyl 3-hexanamine. At the bottom left, we have substituents, bromo, bromo, methyl, methyl, on our longest chain connected to nitrogen that is 5 carbons. The bromo is at carbon 4, so we have 4-bromo. The methyl groups are both on nitrogen, so we have N-dimethyl. And B is before M alphabetically, so our name is 4-bromo N-dimethyl 2-pentanamine. For our cyclic structure, the longest chain bond to nitrogen is the 6-carbon ring. It has a direct bond to nitrogen. And so this is a cyclohexanamine. And then our substituents are the ethyl group and this propyl group. For numbering, the carbon bonded to nitrogen is carbon 1. Carbon 1. The carbon bonded to ethyl is carbon 2. So our substituents are 2-ethyl and N-propyl. And then our name is 2-ethyl N-propyl cyclohexanamine, with the ethyl alphabetically before the propyl. Quaternary ammonium salts are a final group to number. Because it is an ion, it is no longer an amine, it's an ammonium ion. And it has a counter charge, so it will have a salt. It should have the cation, ammonium, and an anion. And the anion could be any number of anions. You should remember your list of anions from General Chemistry 1. So for a quaternary ammonium salt, the nitrogen will be bonded to 4 groups. And if those groups are not identical, they will be listed in alphabetical order. And so for the first molecule at the left, we have a nitrogen with 4 methyl groups. So we can say it is tetramethyl. If you have trouble remembering that tetra means 4, think of the game Tetris. All the pieces contain only 4 squares. So tetra means 4. For the molecules where the groups are not all identical, again, you're going to list them in alphabetical order. So here we have a nitrogen that is bonded to 2 methyl groups, an ethyl group, and a propyl group. In alphabetical order, we would say ethyl, methyl, then propyl. And so when we name it, we list the alphabetical first, ethyl, then we had 2 methyl groups, so we have dimethyl, and then propyl, and then ammonium chloride. So for our summary of nomenclature, you can refer to this chart. It will help you at least identify the suffixes and the tendency of how the general name is listed. For alkyl halides and ethers, the suffix does not change, it is -ane. For alcohols and amines, because they are higher priority than alkanes, the suffix changes. For alcohol, the suffix is -al, and for an amine, the suffix is -amine. All right, next we're going to talk about the structure of molecules and structures of alkyl halides and alcohols and amines, and then beyond to other structures.